Hi everyone, NeuroGal here. Today I'm going to be talking about a device that was recently released on the market called the LIFTID device. It is purported to enhance cognition, attention, and focus through low-level electrical stimulation of the brain. And it is a type of transcranial direct current stimulation device, otherwise known as tDCS. There are a lot of tDCS devices that are available to buy on the market. Some are higher quality than others, but the LIFTID device is a new device. It looks like this. It's fairly easy to use. There are other tDCS devices that are not as easy to use because they're more cumbersome. Every tDCS device uses electrodes, sponge electrodes, to stimulate different regions of the brain. But in some tDCS devices, the electrodes are actually not fixed, so you actually have to place them on yourself, and it could be cumbersome. But with this device, the electrodes are fixed, so this is really hard to put on correctly using a video camera. But obviously it's easy to use, it's light, it's portable. Today I will be discussing the LIFTID device and the neuroscience behind it with the science advisor of the company that created the LIFTID device. His name is Dr. Theodore Schwartz. He is a neurosurgeon and neuroscientist. He completed his undergrad and medical degrees at Harvard and then went on to pursue residency and chief residency in neurosurgery at Columbia in New York. He specializes in the surgical treatment of brain tumors, pituitary tumors, and epilepsy. He also has provided commentary for numerous television shows on ABC, NBC, CBS, and Larry King. So without further ado, let's talk about the LIFTID device with Dr. Theodore Schwartz. Hi, Dr. Schwartz. Thanks for joining me today.
I don't have any makeup on like you do.
Well, it's okay. Thanks for speaking with me today. I know you have a lot of experience with the brain given your successful neurosurgery and neuroscience career. So today I wanted to talk to you about the new device that's on the market called the LIFTID device. It's a type of transcranial direct current stimulation, and it's purported to enhance focus and attention. So tell us about the LIFTID device and how it works.
So before we go into that, just to preface, my role for the company is really as a neuroscience advisor.
Okay.
So I function as someone that they can bounce ideas off of when they have questions about the science of tDCS, how the brain works, how it may impact the brain, different parameters, different locations of stimulation, reviewing the literature, just to keep them on track, make sure that what they're claiming to do is in line with the published literature, that it all sort of makes scientific sense, that they don't overstate what they're trying to do, and that they kind of, stay legitimate. And, I'm happy to do that. Mm-hmm. So the LIFTID device is a method, a technique for tDCS. It's a device that you put around your head like a headband. Mm-hmm. And there it is. You got it.
All right.
And so you push a little button on the bottom after putting some saline and some electrode pads so that it makes good contact with the skin. Mm-hmm. And it delivers stimulation to the surface of the brain through an anode and a cathode. So there's a positive and a negative, just like a battery.
Okay.
And it's direct current stimulation, like the stimulation you get through a 9-volt battery. So as opposed to alternating current, it's direct current. And by stimulating through the skin, it actually can stimulate to some degree the underlying frontal lobe, the cortex that's right underneath the electrode pads. And it sets up a current, and that current does a lot of different things to the brain, which potentially has an impact on brain function.
Obviously, this device is one of many. There are a lot of tDCS devices on the market available to consumers, and the creators of this device specifically placed the electrodes in a fixed position for convenience, but then also to stimulate the frontal region of the brain. Is there any significance to that?
A couple of thoughts on that. First of all, it's designed to be kind of a plug-and-play tDCS device, and there are other tDCS devices that allow you to place the electrode in different locations and maybe change the amplitude in different ways that are more really intended for research. But this is a device where we kind of wanted to control the amount of stimulation, the location of the stimulation, based on the literature and what sort of we felt were the most convincing areas that might lead to the desired effect. So the frontal lobes and the areas we're targeting is the dorsolateral prefrontal cortex, which is roughly in this location. And the truth is, it's a variable. The DLPFC, as it's called, is a target that's defined in many different ways. And the original definition of that target was an anatomic definition. Back in the old days, based on things like Brodmann areas that have to do with the structure of the layering of the cortex. But there was really no evidence that that area had any specific function when it was initially defined, the dorsolateral prefrontal cortex. And it only became something that was interesting with a variety of animal studies that were done, and then some human studies that were done on depression, looking at that area of the brain that lights up or that is suppressed in its blood flow during different cognitive activities. So we're targeting that area because a lot of the studies that are done that were well done for tDCS were done in that location of the brain. So the presumption is, as opposed to putting it in some place that's never been tested and never been studied, this device will give you the highest chance of having some sort of an impact that may be supported with literature that exists already.
What are the primary effects of stimulating the dorsolateral prefrontal cortex?
Yeah, great question. So the first question, I would sort of break that up into pieces, because the first question is, when you put 1.3 or 1.5 or 2 milliamps on your scalp, what is that actually doing to the brain? That's the first question. And then the second question is, location. So what we know is that even that small amount of current, which is a very safe amount of current, and that's been shown in multiple studies, can have an impact on a lot of different compartments of the brain. And as we know, the brain is not only made up of neurons, but there's also blood vessels in the brain, there's glia in the brain, supporting structures, it's got excitatory neurons, it's got inhibitory neurons. And so when we stimulate the brain with just sort of a global current, we really can't control what exactly we're stimulating. So we're depolarizing neurons, but we're depolarizing both excitatory and inhibitory neurons. Mm-hmm. We're also depolarizing glia. And the glia take up neurotransmitters, and that's going to impact the concentration of neurotransmitters in the synapse. We're also changing, endothelia, and we're increasing blood flow to the brain in those locations. That's also been shown. There's fluctuations in calcium that have been shown following low-level stimulation like that in the brain. So it has a variety of impacts in the brain besides just the depolarization of neurons, which it can do, which hopefully puts them in a state where they have a higher chance of firing, they have a higher chance of receiving synaptic information and changing it into long-term changes. Just the fact that you're bringing more blood to that area of the brain, or you're changing the concentration of neurotransmitters based on glia, can have an impact on brain function. The next question is the location. And the DLPFC is an area of the brain that is thought to be involved in a lot of different cognitive functions, including attention, memory, focus, learning. All of those things sort of work through that area. Now, it's not, the brain isn't localized into different compartments. It doesn't work that way. When you do neurosurgery, you open up the brain, you look at it, you don't see areas, and they certainly don't have labels on them. It's just a homogeneous sea of neurons that we put our labels on. We create these sort of artificial zones. There are parts of the brain where we know they have specific functions. So, for example, if I stimulate the part of the brain that is important for moving your arm, the primary motor cortex, your arm's going to move. That is a very well localized area. But we don't have areas like that that are so specific for things like attention. Memory, a little bit we do, but a lot of these functions are distributed throughout the brain. There's widespread networks that are involved in memory, attention, focus, all of that. It's not all in one little place in the brain. Right. And that one focus may be a node within a larger network. It may be a critical area that orchestrates or concentrates some of the widespread activity that goes on with those complex activities. But by no means, is there an attention focus in the brain sitting right there and you're stimulating it and it's lighting up and you're having more attention, because the brain just doesn't work that way with higher order cognitive functions. But what's interesting is that studies have been done where they take individuals in very specific situations who are doing very specific tasks, and they put transcranial direct current stimulation on and they leave it off, and they compare the results and the speed at which certain tasks are done or the number of figures that people can remember. And they have seen some enhancements, and some improvements, even in normal individuals. And that's really what this device is targeting. This is not it's not a medical device, right? We're not treating a disease here. Right. We're taking normal individuals and trying to enhance some of the functions that they rely on based on some studies that have been done showing that, there's a reasonable amount of data that may actually work.
Busy professionals in the Western world, from time to time, some more than others, get tired, and we often rely on chemical stimulants, like caffeine or sugar. But
sure.
This LIFTID device is proposed as an alternative to chemical stimulants to help improve cognition. Based on the studies that have come out, bifrontal tDCS can help with attention and cognition. There are, just based on my evaluation of the literature, there are studies that show no effect, especially in the tDCS literature. There are a lot of mixed results. How do you explain that, and what are your thoughts?
There's no question. What I would say is the literature is muddy.
Yeah.
It's very muddy, and there are both positive and negative studies, and some of the studies are well done. Some of the studies are not so well done. Some of them are well controlled. Some of them are poorly controlled. Some of the tasks are so specific that even if you get a positive result, it may have nothing to do with being in the real world and doing real activities.
Right.
So there is a lot of vagary here, which I think is why, these devices are not FDA approved as a medical treatment for a lot of these things, or we're not, not everyone who has attention issues is walking around wearing one of these devices. So it's still in that phase of being studied, and still in that phase in which we're learning about the effects, about how strong the effects are, about what variables we can manipulate, whether it's amplitude, current density, interstimulus interval, duration. All of that, will require a while to sort out.
Right.
And it may be that there's certain people who are more predisposed to have a positive response to tDCS than other individuals. There could be genetic differences in the way your neurons respond. We're putting the electrodes in fixed locations, but as I mentioned before, in one individual, the node that's important for attention and memory could be in a slightly different location than in another individual. And, we're basing it on, an F3 electrode, which is part of an EEG montage that was designed to basically just cover the whole scalp with electrodes to get good coverage everywhere. There's nothing unique about that F3 electrode. We determined where we were going to put F3 before we started studying F3, and it would be a miracle if we just happened to put it on the most important part of the brain that's important for memory and attention, right? There's no way that that's the case.
Right.
So that being said, it's hard to explain the positive studies. And there's obviously a placebo effect that may be occurring with someone who, is involved in these studies. But, if they're well controlled and if the individual does not know if the device is on or off, then it's hard to say it's just a placebo effect, because you think it would have an effect regardless of whether it were on or off, or whether you were stimulating the anode or the cathode. It would feel the same to the individual. So, having read through the studies and seen some that, I was trying to poke holes in them and trying to read them skeptically and say, why is this study kind of BS? I couldn't really find, a good hole in a lot of the studies that were positive.
Yeah.
So And then I started reading more studies about, does this do anything to the brain? And there's a lot of studies showing that it absolutely does have an impact on the brain. I mean, it's not all getting dissipated in the skin and the skull. About 25% of the current that you apply to the skin actually makes its way down to the brain. I also have a lab that I run that is an epilepsy lab, and we look at the effect of stimulation on the brain, electrical stimulation. And we did these interesting studies in humans where we were stimulating the cortex and we were measuring blood flow into the brain. And we saw these dramatic changes in blood flow in the brain with very low levels of cortical stimulation. And it got me realizing what a profound impact even small levels of cortical stimulation that may not be causing action potentials to fire in neurons can have an impact on the supporting architecture of the brain and really change brain function, particularly if it's done over long periods of time.
There's a lot of talk about neuroplasticity and the use of tDCS. What are your thoughts on strengthening the, say, attentional or concentrational networks after persistent use of tDCS? Is that possible?
Yeah. So, the model of learning in the brain, the classical model is this sort of Hebbian model. And that's sort of a complex word. What it basically means is that a neuron will take in information from an adjacent neuron that sends an electrical signal, and that will depolarize the soma, or the body of the neuron a little bit. And at the same time, another neuron will send information in that will depolarize that neuron a little bit more. And if you have 20 different neurons firing at the same time onto one neuron, then it will be depolarized even more, and it may itself fire an action potential. And that's really the learning that goes on, is that the more certain neurons that fire cause an action potential in a cell, the more likely that additional firing of those neurons will in the future cause an action potential in the cell. So the neuron, the single cell, is basically remembering which are the neurons around me that like to fire to cause me to fire. And I'm maybe going to fire even more quickly next time those neurons fire. So there's literally memory within an individual cell in the brain that can be enhanced or diminished based on the firing of adjacent neurons. So if you believe that model, and and we've shown it's been shown to be true in multiple areas in the brain, then what tDCS could do is slightly depolarize a neuron, almost like a synaptic information coming in from adjacent cells, depolarize a little more, and make it more prone to firing when the adjacent cells fire, which may enhance that neuron's ability to fire in the future when those cells are firing. So it's almost like a training device that is helping create that connection, because that's how connections are formed in the brain, based on simultaneous firing of neurons. Action potential is firing. And if anything that can facilitate that, whether it's a drug, potentially facilitate it, enhance memory, or depolarization of certain parts of the brain to enhance memory, in theory, it could work.
Yeah. It could work. What should a person be doing when they're using the tDCS device, the LIFTID device?
Yeah. I would say it's hard to give specific advice to that. But I think, for example, if you are a musician, right, and you're practicing how to play a passage, and that's done through repetition, right, where you're sort of stimulating certain neurons in the brain again and again in the same pattern until they fire really well together. It's not just your hands getting faster when you're learning something. It's a change in your brain that's making that happen. It's possible that wearing the device and depolarizing those parts of the brain that oversee that ingraining of that memory could enhance one's ability to play that instrument. Or if you're doing a video game, and you're playing and you want to be sort of taking in information, predicting the future, and responding as quickly as possible, because there's other papers that show that the dorsolateral prefrontal cortex its primary function may literally be predicting the future, and trying to predict and integrate emotions and integrate what we're feeling and thinking and what we want to do with what we're going to do as sort of a temporal integration area. If that's the case, then if you're playing a video game and you're wearing the device, you could imagine that your ability to anticipate and respond could be enhanced. And the more you're in that situation again and again and again, the more it would be enhanced. So it wouldn't just be the first time, but it could be over time, again and again and again, because you'll be learning with each additional exposure.
Okay. With that knowledge, how often should someone wear the device, and is it possible for someone to overuse it?
Yeah, it's a great question. So there have been literally thousands of studies on tDCS, and there's almost no side effects or negative consequences of using it because the stimulus really is quite low. We don't recommend, if you have a neurologic disease, that you use this particular device, particularly something like epilepsy or Parkinson's disease. But it's designed to be worn for 20 minutes a day. There's no evidence really that if you use it indefinitely, there'll be a negative consequence, but it's never been studied really, right? So if you look at the studies out there, there's no study that says if you do tDCS for a year straight, what will happen?
Yeah.
So the truth is, we don't really know. But based on all the stimulation that's been done and what we know about the brain and the negative consequences, I think it's highly unlikely that over a long period of time there will be a negative consequence. Obviously, if you feel something funny when you put it on, you don't feel well, or you should probably take it off. It's probably not helping you. But if you feel fine and you're using it for 20 minutes a day, then you're okay.
Well, thank you. This is really helpful, very informative. Is there anything else that you'd like to add before we end our talk?
It's been a pleasure being on your podcast or show. I think we've been pretty comprehensive in what we've talked about. And I guess what I hope to do in my role with LIFTID, I would add, is that, from time to time people post comments or questions, or there's debates online. And I like to write sort of scholarly articles that look at the literature on that subject and give sort of my interpretation and my opinion about different scientific questions. So if you have specific questions that you want answered, by all means, you can put them on a website or our website or a review, and the people who work there, if they read it and send it to me, at some point I'll try to address that, with some references into why I think what I think and where I get the information from.
Great. And this is the LIFTID website?
Yeah.
Okay, great. So I will put the link to the website in the description box of our video for anybody interested. And thank you again, Dr. Schwartz. I really appreciate it. And it was great talking with you.
Yeah, it's great meeting you.
Yep. Take care.